Hi there, and welcome to the first lesson in this shell scripting course. My name is Jason Cannon, and I've helped thousands of people just like you level up their careers by teaching them valuable in-demand Linux skills. I've created many Linux courses, and I've written several best-selling books on the subject too. Now, that's enough about me. Let's get to the reason why you're here, which is to learn about shell scripting. A shell script is simply a plain text file that contains a series of commands and shell statements. When a shell script is executed, it in turn executes the commands listed in the script. It starts at the very top and executes the commands on each line, one line at a time, until the end of the file. Executing a shell script produces the exact same result as you typing in each line directly into the terminal. This means any work you can do on the command line can be automated by a shell script. And the converse is true as well. Any of these shell scripting techniques you learn to use in your shell scripts, you can also use them on the command line. As you can see here, I have a terminal open on my Linux system. Personally, I'm using CentOS, but any Linux distribution will work for this course. Because shell scripts are text files, we need a text editor to create and edit our shell scripts. If you already have a favorite text editor, such as Vim or Emacs, go ahead and use that. If you don't have a favorite text editor and you're not familiar with those other tools, I suggest starting with the Nano text editor as it's simple to use and easy to learn. The only downside with using Nano is that you may have to install it first. Some distributions don't include it by default. To install it on a Red Hat-based Linux distribution such as Red Hat or CentOS or Oracle Linux or Scientific Linux, you use the commands sudo yum install -y nano. Now in my case, the package is already installed, so it's not going to do anything. If it wasn't installed, it would download it and install it, and I would be ready to go. Now, if you're on a Debian-based Linux distribution such as Ubuntu or Linux Mint, you can use this command, sudo apt-get install -y nano. I'm not going to execute this command on my system because, again, I'm using CentOS, and this command is for Debian-based Linux distributions. So I'm just going to type Control-U to clear the line of text. So now let's go ahead and create our first script. We'll call it day1.sh, and here, like I said, I'm using Nano as the text editor. So I'm just going to type in the contents of this shell script. Okay, now that I'm done, I could just hit Control X here on Nano to save my changes. It asks me if I want to save it, and the answer is yes, so I'll hit Y. Then it asks me what the file name is, and of course we already specified the file name, day1.sh, and so I'm just going to hit Enter here to save my changes. Now, before you can execute this file as a script, you need to give it execute permissions, and we can do that by using chmod +x day1.sh. And by the way, chmod is short for change mode, with mode being another way to say permissions. The +x in the command gives the file execute permissions. So now we're ready to run this script. So we do that by typing a dot or a period, a /, and then the name of the script, and then hit enter. I'm going to quickly remove this script and then show you what would happen if you forget to use the chmod command. So I'm going to delete it with the rm command, and then I'm going to recreate it with my Nano editor. I'm cheating, I'm pasting in the contents here, I'm saving the changes. And if you forgot to run chmod, you would end up with something like this, a permission denied error. And so if that happens, all you have to do is run the chmod +x command, and you'll be ready to go. So this simple 2-line shell script doesn't necessarily do anything that exciting, but it gives us an excuse to learn some important things about scripting. The first thing to know about shell scripts is that there's nothing special about the file name for this script or any shell script. By convention, shell scripts end in .sh, but the file extension is not significant like it is in some other operating systems. As a matter of fact, you can name your shell script anything so long as it's a valid file name. Let me go ahead and create a scratchpad here. I'll just call it notes. And I want to give you some examples of some valid shell script file names. We could have named this day-1.sh, day_1. We could have even used mixed case, for example, a capital D and a capital O. We can even start our names with an underscore. D1 would be an example of a valid file name and thus a valid shell script name. Okay, I'm going to exit. I'm not going to save my changes there. Now, when it comes to shell scripts, if the file name doesn't matter, then what does matter? Well, it turns out that it's the file's permissions that matter, and more specifically, a shell script must have executable permissions. Use the ls-l command to view the current permissions on a file. So here I just listed all the files in my directory. I could have specified just the one file I want to look at like this by specifying it after the ls command. So I have the permissions string highlighted on your screen, and we're going to break down each little character of that in just a second. So that is the initial permissions I had on this file when I initially created it. So here's what happens when we run the chmod command. So I'll do chmod +x day1.sh and then run my ls command again. So now the permissions string has changed. With permissions, R stands for read, W stands for write, and X stands for execute. The very first character in the permissions string tells you if it's a file or a directory. So here it's a dash, which indicates a file, and if it was a D, it would be a directory. The next three characters represent the permissions of the owner of the file. The following three characters represent the permissions that are granted to the group of the file. And the last three characters represent the permissions that everyone else on the system has to this file. By the way, you can tell who is the owner of the file and what group the file belongs to by looking at this ls output. The owner is listed first, and in this case, it's Jason because that's the account I used to create the file. The group is listed after the user, and the group for this file is teacher. The reason this file is in the teachers group is that's the default group I'm in on this particular system. So now you have every bit of knowledge you need to know the exact permissions for this file. So in this example, the Jason user has read, write, and execute permissions. The teacher group has read and execute permissions, and everyone else who is not the Jason user or who is not in the teacher group has read and execute permissions to this file. In order to execute the script or the file, you need to have both read and execute permissions on that file. If you can't read the file, you can't execute it because, as you already know, the commands are read in from the file. And again, if you can't read it, they can't be read, and thus they can't be executed. So if you still get a permission denied error after running chmod +x day1.sh, then try chmod +rx day1.sh, which gives you read and execute permissions to the file. So that brings us to the end of this first lesson, where you learned the absolute basics of creating a shell script. You learned how to name your shell scripts, how to give them execute permissions, and how to run them. I want to acknowledge that you're off to a very good start, but we haven't even talked about the lines inside the shell script yet. And that funny looking first line is really important. Hi, and welcome to lesson 2 in this shell scripting course. In the previous lesson, you wrote a script called day1.sh. And so let's look at the contents of that script. Here you can see this simple script has 2 lines. And by the way, the cat command is short for concatenate, and by default, it displays the contents of files to the screen or on your terminal. Now, the first line in this file is called a shebang. And the reason it's called a shebang is that the pound sign is sometimes called a sharp. If you can read music, you know that the pound sign looks very similar to a sharp sign in musical notation. Many people call a pound a sharp. Also, the slang term for an exclamation point is bang. So the pound sign followed by an exclamation point could be spoken as sharp bang. An exact contraction of those words is actually shebang, and that's where the term shebang comes from. You want to start out each shell script with a shebang followed by the path to an interpreter, which is /bin/bash in our case. When you execute this script, the commands inside that script are executed by /bin/bash. And so remember that this first line, the shebang, determines what program executes the commands listed in the file. If you don't supply a shebang and specify an interpreter on the first line of the script, the commands in the script will be executed using the current shell. Now, that may not be what you want. For example, if you have some bash specific items in the shell script and you happen to be using the CSH shell, when you execute it, you are going to end up with some errors. Now, this is really important if others are going to execute your scripts because you have no control whatsoever over what login shell that they'll be using when they execute your script. That's why it's best to be very explicit and always use a shebang and supply the interpreter. As a reminder, in the previous lesson, you added executable permissions to your script by running chmod plus x and then the name of the script. And then you actually executed or ran that script using a period and a / followed by the script name and then pressing enter. We already talked about the importance of permissions in the previous lesson, but we didn't talk about what is going on when you type that / and then the script name and then hit enter. So let's break that down. The period, which some people call a dot, like myself, represents this directory. For example, if I type in cd space dot and hit enter, I don't go anywhere because dot is the current directory. And by the way, if I use the pwd command, which stands for present working directory, we get the present directory or the current directory. On a related note, dot represents the parent directory. So if we type cd space dot, we move into the parent directory or the directory above the current directory that we were in. So if I do pwd now, we're in /home. So let me change back to my home directory. The / is the directory separator. So ./day1.sh is the current directory, followed by a directory separator, followed by the script name. That's how you execute a script in your current directory. So // and then the name of the script. This is equivalent to using the full path. And full paths start with a /, and they're very specific. So in my case, I could actually run /home, /json, /day1.sh, hit enter, and I get the exact same results because I'm running or executing the exact same script. The reason why ./ works is that dot represents the current directory, which is /home, /json. Then we specify another /, which is the same as /home, /json, /, and then finally we provide the name of the file, which is the same as the name of this file, home json day1.sh. So long story short, just remember this pattern that you create a shell script, you run chmod plus x to that shell script to make it executable, and then you run // and then the name of that script to actually run it. The other line in the shell script that we haven't talked about yet is the echo statement. It says, echo, I don't have to be great to start, but I have to start to be great. Now, as you've probably figured out by now, the echo command just displays whatever is passed to it. But where does echo come from? It's actually a shell built-in, which means it is a command that is built into the shell and doesn't require any external programs to execute. It's just part of bash. How do you know that it's a shell built-in? Well, you can use the type command, which is also a shell built-in, to show you if a given command is a shell built-in or not. So let's do this. We'll do type echo and press enter, and the type command reports that echo is a shell built-in. Now, if you want to see all instances of echo on your system, use the -a option to type. So we do this, type space -a space, and then followed by the command you're interested in. And here we're looking at echo. The type command lists the echo commands in the order that they will execute. The shell built-in is listed first, so that is what gets executed when you type echo and press enter. Even though I don't recommend it, you can force the execution of another option by using its path. For example, we could use /user /bin echo and then provide some data to display to our screen here and hit enter, and sure enough, it displays it back to our screen. Now, anytime there's a shell built-in, I want to recommend that you go ahead and use it. Do not specify the full path. Using shell built-ins is slightly more efficient because the shell doesn't have to request an external program to do the work. But the most important advantage of using shell built-ins is that your scripts become portable. For example, if the echo command is located at /bin /echo on some systems and user bin echo on other systems, then you might run into an issue by specifying the full path. And then on some systems, echo is available at both places, so it won't be an issue. But in any case, when you use the shell built-in, you avoid that issue altogether. You can think of built-ins as free stuff you get by using bash. In addition to built-in commands, there are other built-ins, including variables, that you'll be learning about soon enough. Before we wrap things up for this lesson, let's write a script using something new. Let's use a variable in our script. So let's go ahead and call this script day2.sh. Of course, we always start our scripts with a shebang, so we know what the first line is going to be. It's going to be shebang /bin/bash. Now I'm going to create a variable here called skill, and I'm going to assign it a value of shell scripting, and then I'm going to display that to the screen. Now I'm going to save my changes and set the proper permissions and execute the script. Let's display the contents of this script while we talk through it. On the second line in this script, we assign the value of shell scripting to the variable named skill. Now, variables are simply storage locations that have a name. You can think of variables as name-value pairs. When you access the variable of skill, the value that is returned is shell scripting. Unlike some other programming languages, when you create a variable, you don't specify its type. It doesn't matter if the value is a string or if it's an integer or a float or anything else. You simply assign the value to the variable. It's very important to know that there are no spaces around the equal sign. So the syntax is variable name without any spaces, an equal sign, and again without any spaces, the value that is surrounded by quotes. Now, if you have a space before or after the equal sign, you'll get a command not found error message. So we're going to stop here for this lesson. And in this lesson, you learned what a shebang is and the importance of using one. You also learned that the echo command you used in your script is a shell built-in. More importantly, you learned how to tell if a given command is a shell built-in or not. Finally, you were introduced to variables. There's plenty more to learn about variables, so that's where we'll pick up in the next lesson. For example, you'll learn why I capitalized the variable name in this script. Plus, you'll be introduced to even more new shell scripting techniques. Hello and welcome to another lesson in this shell scripting course. In the previous lesson, you wrote a script called day2.sh. Let's take a look at that real quick. In this script, you assign the value of shell scripting to the variable named skill. Now, we kind of glossed over this yesterday and we didn't cover the rules around naming variables, so let's do that now. To start off with, variable names can contain letters, digits, and underscores. However, variables can only start with letters or underscores. They cannot start with a digit, also called a number. So here are some examples of valid variable names. So we already have skill, capital skill, like we used here in this particular script. We could also add a digit to that. We could say skill 1. We could also use an underscore and start our variable even with an underscore. Now, here are some examples of invalid variable names. 3skill is invalid because it starts with a digit. A dash skill is invalid because it has a dash in it. And again, variables can only contain letters, digits, and underscores. In the same type of vein, if we do something like this, e@mail, again, we violate this naming rule, and that is not a valid variable name. By convention, and not by rule or syntax, variable names are in all uppercase. This way, you can quickly spot the variables in your scripts. You can use lowercase or even mixed case variable names, again, because the uppercase is just a convention and not a rule. So you could use all lowercase skill, you could use mixed case, like these other two examples here on your screen. So those are all valid variable names. Okay, let me delete these lines here from our test. When you reference a variable by name, you get its value back. And to do that, you enclose the variable name in curly braces and precede it with a $sign. So when you want the value of the skill variable to be returned, you use $, opening curly brace, the name of the variable, which is skill in this case, and a closing curly brace. And that's exactly what you did in this particular script. Another less strict way to use variables is just by preceding them with a $sign and omitting the braces altogether. So you could have done something like this. Sometimes shell scripters are being lazy and they just use that simple $sign variable name syntax instead of including the curly braces. However, if you want to immediately proceed or follow the variable with data, you have to use the curly braces. If you don't, then Bash doesn't know where the variable name starts and where it ends. Just going to exit out of this script and not save my changes. And I'm going to go ahead and create another script here called day3.sh. And then let's use this script to demonstrate the variable syntax that we need. Of course, we're going to start out all of our scripts with a shebang. We're assigning the value of script to the variable named word. Okay, let's save our changes here. Add the execute bit to our script. And then run it. Okay, let's look at the contents of this script so we can talk through it here. Now, by using the $sign opening curly brace, word closing curly brace, ing, Bash knows that you are referencing the variable named word and that ing is not part of the variable name. If you were to do something like the following, you would not get the desired result. So let's edit our script here and do this. Save our changes and then execute it here. This causes Bash to return the value for the wording, wording variable, which does not exist. Because the variable doesn't exist, nothing is substituted for it. So that's why we get the output we do as you see here on your screen. So just get in the habit of always surrounding your variable names with curly braces, and that way you won't run into any of these type of issues. Now, however, you will see other scripters who are frankly not as good as you are at this point use the lazy $sign variable name syntax. So just know that it exists and know what it does, but also know that it can come with its own challenges. Now, using that variable of capital WORD, lowercase ing, made me think of an important point that you need to be aware of, and that is this: capitalization matters. For example, these three variables are entirely different. They're completely different variables. So if we assign the value to all uppercase word, you cannot get its value by looking at all lowercase word or using the capital W lowercase ORD. The case has to match exactly. So this is another reason to conform to the convention of using all capital letters for variable names. When you learn and apply these little best practices and tips, you end up saving yourself from wasted time, troubleshooting, and debugging strange little errors in your script. Let me remove these lines that we're testing with here and add some more code to our script. Let's do this. Okay, let's save our changes and execute this script and see what we have. So what you've actually done here is something called variable reassignment. You initially assigned the value of script to the variable of word, then you accessed that variable in the echo statement, and then you reassigned a value to word. This time you used read as the value, and then when you executed echo on the next command, you found that it reflected that change. So the first line of output is scripting is fun, and then the next line of output is reading is fun, due to the variable reassignment. So if you ever want to change the value of a variable, simply create another assignment statement. And remember that scripts are read and executed from the top to the bottom. As you start to write longer and more complicated scripts, you'll want to use comments. If you need to update one of your scripts, let's say a year after you initially wrote it, having a few notes in the script really helps you out. The same is true for someone who is looking at your script for the very first time. To create a comment, start a line with a £. Comments are not executed. They're just simply there for us humans to read. The shebang is the only exception. In all other cases, the information following a pound sign is just there for us humans. Anything you put after the pound sign will not affect the functioning of your script. Now, one comment I highly recommend that you use is at the very top of your script stating what the goal of the script is or what happens in general when the script is executed. For example, we could use this as the header or opening comment for the script we're working on today. You can also use comments to describe what a command does or what a series of commands do. For example, you might use this comment before the first variable assignment. Another place we may add a comment is above our variable reassignment here. We could say something like this. Comments act as a shortcut to determining what the script does. They are inline documentation, if you will. If the commands are relatively simple and self-explanatory, then you can skip commenting them. Using blank lines can make your scripts more readable. They can be used to visually separate logical blocks of code. Like comments, blank lines do not change the operation of your script. So let's add some blank lines to our script. Let's put a blank line above and below the initial comment of our script. And let's also use a blank line to visually separate two logical blocks of code here in our script. Let's put a blank line here, and that way you can see there's one chunk of code that goes together, and then the next chunk of code goes together. Now let's save our changes and execute our script. So here we see scripting is fun and reading is fun, which is the exact same output that we had before we added these comments and blank lines. Again, the comments and blank lines don't affect the execution of the program. They're just there to make things more readable and easier for us humans. So that brings us to the end of this lesson. And in this lesson, you learned the rules for naming variables. You also learned that capitalization is important. And finally, you learned how to use comments and blank lines to make your scripts easy to read and understand. In the next lesson, I'm going to share a method with you that can make writing long and complex shell scripts really simple. In the previous lesson, you learned how to add comments to your scripts. You also learned it's a good practice to start your scripts with a comment or a header that describes the goal of the script. One of the things that you can do to help you write shell scripts is to think about all the steps it takes to accomplish that goal and then create a comment for each step. Those comments are called pseudocode. It's like creating an outline of your script before you start scripting. So let's try it. Let's write a script called sysinfo.sh. Okay, each script starts with a shebang, and then we're going to have our opening comment, which is the goal of this script or the reason why this shell script exists. So this script is just going to display some information about the system on which it was executed. So the next step is to think of how to accomplish that goal. In this example, you would think about all the information that you want to display. So let's say you come up with this list. The first thing we want to display is to tell the user that the script is actually starting. Next, let's display the host name of the system. From there, let's display the current date and time when this information was collected. Let's get some information here about the kernel. And then let's display some disk usage information. And let's say this is all the information that we want to display. So let's just tell the user that the script is done. Now that you have your shebang, header, and pseudo code, it's time to start filling in the actual or real code. Now let's go back to the first comment here, and it says tell the user the script is starting. So that's easy enough. We can use the echo command. The next thing we need to do is display the host name of the system, and one way to do that is simply use the host name command. Next, we want to display the current date and time, so we can do that with the date command. To get information about the Linux kernel, you use the uname command, and specifically the -r option displays the kernel release, and the -m option displays the architecture or the machine hardware name. So let's have two commands here. One is uname-r, and the other is uname-m. Next, we want to display the disk usage in a human-readable format. And one command we can use to do this is actually called df, which stands for disk free. You can tell df to display disk usage in a human-readable format by specifying the -h option. So instead of listing 1 and a bunch of zeros, for example, it will say 1M for 1 megabyte, 1G for 1 gigabyte, and so on. The last thing we need to do here is tell the user that this script is over, it's done. So let's save our changes, and of course, set the permissions, and then execute our script. The more complex scripts you write, the more important pseudo coding becomes. It allows you to write amazingly complex scripts by simply breaking them down into easy-to-script pieces. So that's all for this lesson. I hope you enjoyed it. In tomorrow's lesson, you're going to learn about shell built-in variables and how to make decisions in your scripts. Hi there, and welcome to another lesson in this shell scripting course. Let's talk about humans. Specifically, making decisions is one of the things that we do as humans. Every day you're confronted with many choices, and it's up to you to choose the right one. When you start automating your work with shell scripts, you have to put your good decision-making abilities into your scripts. One way to do this is by using if statements. In real life, we use an if framework to make decisions. For example, if something is good for you, you go ahead and do it. And if it's not, then you don't do it. Let's create a script that displays if the user running that script is using the root account or root privileges. We'll call this got-root.sh. Okay, you know what goes on the first line, the shebang. And you also know that we're going to put a comment or a header at the top of our script. Let's start out by displaying the UID, which is also known as the user ID of the account that is executing this script. And we can do that with the bash echo built-in. In addition to built-in commands such as echo, bash gives you built-in variables too. One of those built-in variables happens to be UID, which contains the user ID of the person executing the script. And by the way, that is a number. We can actually use this number to make a decision in our script. By the way, the UID of the root user is always 0. On every single Linux system you ever encounter, root is always UID 0. And that's why we can use it to test to see if a user is root or not. So let's do that with an if statement. We're going to use if, a space, double brackets, another space. Now these spaces are very important. You need those spaces here in the if statement. Now let's check to see if the UID is EQ, which stands for equal to 0. All right, and we'll close our test there with the double closing brackets. We close the if statement with the reverse of if, which is fi. So here's how the if statement works. We use an if statement by putting a test inside of those double brackets. If that test turns out to be true, then the commands following then are executed. In this example, when the UID is in fact equal to 0, then the command echo urroot gets executed. If the test is not true, then the commands following the else keyword are executed. So in this case, if the UID is not equal to 0, then echo you are not root is executed. By the way, I want to point out a couple things here. You can have multiple commands here. So you can have several commands in this code block. It's the same thing with this code block as well. You can have several commands here. Another important thing to know about this, as I briefly mentioned earlier, is spacing. So this is the proper spacing in an if statement. If we do something like this, we're going to get an error. Notice how this is the wrong way to do it, and there's no space after the opening brackets here. So another error would be to do this, not include a space there. So you need a space after if, and you need a space after the double opening brackets, and also you need a space right before the closing double brackets. Now it's actually okay to do this. You can have additional space, but you need to have at least one space. So let me get rid of that extra line. I just wanted to point that out to you because it is a common problem when you're first starting to work with if statements. As I already mentioned, -EQ represents equal. If you want to use not equal, you use -NE, -LT stands for less than, -GT is greater than, and -GE is greater than or equal. And so those are arithmetic test operators. That's what you use when you're comparing or testing numbers like we are here. If you want to compare strings, you use an equal sign. Again, we're using numbers, so we're using -EQ. If you studied shell scripting at all in the past, or maybe you've just looked at some sample shell scripts, you might have seen if statements that use single brackets. They would look like this. Let me get rid of that bracket and that bracket. So that may be something you've seen in the past. The single bracket syntax is an older syntax. This new double bracket syntax is the latest and preferred syntax. So let me go ahead and put that back. That's what I'm going to use in this script. You can think of the single bracket syntax as being replaced with the double bracket syntax. Again, I just like to point this out because you'll still see some old scripts written this way, and even new scripts written by people who aren't caught up with the times. And right now, since you know about this double bracket syntax, well, you're ahead of them. The main advantage of using double brackets is that it comes with less surprises. It really does what you think it does, and it does what you want. You can run into issues when using single brackets, especially around quoting variables, file name expansion, and using operators. Okay, so at this point, I think you understand what this script does. It displays the user ID, the number of the account that is running the script, and then it tests that number against 0, which is always the UID of the root account, and then it displays a message based on that result. So let's save our changes, add the executable permission, and then go ahead and run our script. If you're using a normal user account like I am here, you'll see this output. You'll see a UID that is something other than 0. And then, of course, the echo statement that gets executed is the one that says you are not root. One way to execute the script as root is to use the sudo command, sudo. And by the way, you may or may not have sudo privileges depending on the specific configuration of the system that you're working on. The root user is also known as the super user since it can do anything. So sudo stands for super user do. So let's try it out. Sudo got root. So this time we get your UID is 0 and the echo statement that gets executed is the one that says you are root. If sudo isn't configured on your system, you'll see an error message like you are not in the sudoers file, and that's okay. Because there's another way to execute the script as the root user, which is to first switch to the root account. You can switch to the root account with the su command, which you can think of as standing for switch user. So when you execute su, you're prompted for root's password. So let me enter it here. And now I am root. And you can see that I'm root because the prompt changes. It has a $ instead of a $, and that's a pretty standard convention for the root account. So now I can go ahead and execute this script, and it recognizes that I am indeed the root user. Now to log out of the root account and get back to my normal account, I just type exit and hit enter. So now I'm back to my JSON account on this Linux system. It's a good practice to check for any requirements or dependencies that your shell script relies on in the script itself. For example, if you write a shell script that installs software, you want to make sure the person executing the script is using root privileges because root privileges are required to install software. You just don't want to assume that they know that or that they're going to automatically do that. You want to check for it and enforce it. So let's edit our script again and change it slightly such that it could fit this example. So here we're checking to see if the user is root. And if they are, we could do something like this. We could say installing software. Let me get rid of this line. And then I would go ahead and then put the commands here to do the software install. And then if they are not root, then we could just tell them that. Say, you do not have permissions to install software. I'm going to exit out of this script and not save my changes. I just wanted to show you a real world example where you can use that specific if statement. So that was a little introduction to the if statement and also a little introduction to some of the shell built-in variables that are available. Again, we only covered one of the many that are available. I sincerely hope that you enjoyed this mini crash course into Linux shell scripting. If you followed along, that's great, and you're off to an awesome start. But as you can probably guess, you just barely scratched the surface of what's possible with shell scripting. So if you're ready to take things to the next level and get serious about shell scripting, I want to invite you to my full-blown shell scripting course. It's designed so that you can learn 90% of everything you'll ever need to know about shell scripting in the shortest time possible. To learn more about the course and what it can do for you, click the link below this video. If you're serious about shell scripting, I encourage you to join me and the other students in the course by enrolling today. All right, I hope to see you there.